In Lecture 2, we will discuss digital audio, how it is recorded, the file formats that are used, as well as how speech is generated on a computer. Digital audio was invented by James T. Russell in 1966. Philips first proposed a digital audio format in 1974, and the CD was developed by Philips and Sony in the early 1980s. Digital audio includes music, speech, and other sounds that can be represented in memory as ones and zeros. These are used by the computer's processors to recreate sound that the computer can output through its speakers or headphones. Most digital devices these days have microphones built in. Many portable devices will also have speakers built in. Audio software comes standard these days, so recording sounds and playing them back on your computer and other digital devices is not difficult at all. Before we can continue talking about digital audio, we need to define what digital is and how it is different from analog. The real world, the world that we live in, is analog. As I enter a highway and accelerate to highway speed, my car will go through every value of speed from 0 to 50 miles per hour. There are literally an infinite number of values between 0 and 1. There is 0.5, there is 0.1, there is 0.01, there is 0.001, there is 0.0001, and so on. When we work with these real-world values, which we call analog, we accept that the actual number of miles per hour is going to be rounded off to the nearest mile, or tenth of a mile, or hundredth of a mile, or so on. Analog values are continuous, with any of these intermediate values being possible. This is not the case on a computer, where there is nothing between 0 and 1. Those are our only choices. Of course, we can use them to approximate analog values, but they are not the same thing. For computers to work with analog values, we need to store them in a way that is recognized as being as close to the actual value as possible. And just as the number of miles per hour is continuous in the real world, so is the passing of time. We will need to work at discrete instants of time, and we will read the value that we are looking for at these instances of time. To do this, it will save samples of the sound waves because it is impossible to keep track of every instance. Therefore, we sample thousands of times each second. The computer must take this analog value and represent it as a digital value. For this purpose, we use devices called an analog to digital converter. When we are looking to play back that sound later, we need to convert it back into its original analog form. For this, we need a digital to analog converter. This slide shows an analog curve that is being sampled. We are able to get a value of the height of the curve at regular intervals. Let's just say every tenth of a second. These sampled values are interpreted as vertical segments. In other words, we assume that the height of the wave does not change over the interval. When we follow this sample with another, a tenth of a second later, then another, and another, we can approximate the wave in a digital sample. And the shorter each time interval is, the closer our samples get to representing the analog data from which the sample comes. As we saw earlier, the sampling rate is the number of times per second that we will sample the data, or, in other words, measure the sound that we are recording. As we saw before, the higher the sampling rate, the closer we get to the original sound. but it also means that there is a greater amount of data that we need to save. Our goal is to sample frequently enough that our data sounds like the original sound, but not more than that. There are different file formats used for audio files. In some cases, the file format may determine the software that you will need to play the file, although most media players can read and play files from more than one format. The most popular audio formats are the ones you see listed here: AAC, MP3, OGG, Vorbis, WAV, FLAC, and WMA. AAC stands for Advanced Audio Coding. This format will produce very good sound quality despite using a lossy compression algorithm. It was developed by Apple for playing on iPods, iPads, and iPhones to encourage recording companies and artists to allow them to play their works on Apple devices. It included copy protection, so use of these files were limited to approved devices. MP3 became a very commonly used format. Like AAC, it uses lossy compression and provides good sound quality. It is commonly streamed over the World Wide Web. OGG Vorbis is an open standard, and like AAC and MP3, it uses lossy compression. While some browsers support it, its popularity is more limited than AAC and MP3. It is part of Google's WebM format. WAV was developed by Microsoft and IBM, and was the format used with Windows, although it is also compatible with Linux and Apple's iOS operating systems. It provides good sound quality, and browsers typically will support it without a browser plugin. Its main disadvantage is that it does not compress its audio data, so the files will be much larger than an MP3 file for the same soundbite. FLAC provides excellent sound quality. It uses lossless compression. WMA uses either lossy or lossless compression. Files can be copy protected. This has been replacing WAV as the most common audio file format on Windows-based computers. Compact discs and digital video discs were designed to be played in CD players and DVD players. They have their own formats, and these formats are different from the Windows and iOS formats used for CDs and DVDs. While computers have software that can read those formats, most people will reformat the files so they can be played on other devices, including on smartphones. The formats that these files are converted into use compression, so the reformatted file will take up less space. Reading tracks from a CD or DVD and converting it to a computer's usual format is called digital audio extraction, although most people simply call it ripping. When you copy a file from a network or an internet service provider to a local device, it is called a download. Downloads are not the only way to acquire audio files. They can also be acquired as a live stream, when it is actually being broadcast, or an on-demand stream, when you elect to receive a download of a particular file. These three methods are different. While a download means that you can play it whenever you want after downloading, this is not typically true for streaming. With live streaming, the content can't be paused, stored, or rewound. On-demand streaming is a little different from this. The content is stored temporarily until there is enough content that you can actually play it. Unlike live streaming, you can fast forward to any point in the stream without having to wait for the entire file to download. If you are looking to play an audio file, you need audio software to do it. This can be either an audio player, an audio plugin, or other audio software. An audio player is either a standalone software application or a mobile app, a small program that you can run on your smartphone. The term can also apply to separate dedicated devices, although these are no longer as common. A plugin is a software component that can be added to an existing program. The term is most commonly used with respect to web browsers. An audio browser plugin will allow you to play an audio file through your computer's web browser. The audio software that we are talking about is somewhat general-purpose software which can also be used to record or modify audio files. Apple's iTunes, Windows Media Player, and Audacity are examples of this. Audacity is an example of an audio editor which you can use not just to record or play sound bites, but to edit them in a variety of different ways. The term MIDI stands for Musical Instrument Digital Interface. It is a standard that specifies how music data is to be stored for synthesizers, electronic MIDI instruments, and for computers. The information that it stores will specify notation, pitch, and tempo, among other things. In the example that you see here, we can tell that the note is on or can be heard. The sound is from a piano. We can tell that the note is high C and it's fairly loud. Musical composition software will allow the user to place notes on a screen-based music staff and then can play it back so you can hear what it sounds like. Not everything that we listen to on a computer is music. We will frequently listen to human speech. Speech synthesis is the manner in which computers produce sound that sounds like a person actually talking. This is different from speech recognition, which refers to the ability of a machine to understand words spoken by the user. This is more challenging than having the computer speak to you. Speech recognition software analyzes what someone says, but first converts each word into a series of basic sounds that appears in the user's language. These basic sounds are called phonemes. Then these groups of phonemes have to be compared to words in the program's digital dictionary. Once it finds a match, the software carries out the command that the user makes, or it can display the word on the screen. Over the past decade, there have been a lot of advances in speech recognition. We have seen automated phone answering systems and digital assistants such as Alexa that can understand spoken language. Siri, the digital assistant on iPhones, provides an example of digitized speech. The actual voices of Siri were created by live actors. They cannot anticipate every answer to every question that users will ask, so they record words and sentences from a script that is designed to provide them with recordings of a wide variety of phonemes which can be loaded into a linguistic database. When Siri formulates its answer, it can take the necessary phonemes and construct a spoken response based on them.